Going on, guys? In this video we are going to see how to find unknown voltages using nodal analysis by inspection method. Now in order to do this one we have to follow all these 6 steps. Let's go one by one. The first one is find a reference node with a known voltage. Now to find the reference point, what we do is we just connect the bottom part to the ground. So in that way the bottom part will be 0 voltage, so we don't have to deal with this. Now let's look at the next part. Assign voltage to the other nodes. So other than this bottom one, we have this one. So let's call this one V1 and let's call the other one V2. And these are the 2 nodes left. And then assign conductance to resistor. Now here we have 3 resistors, and conductance is 1 over resistor. So 6 ohm, we have 6 ohm right here, so the conductance is going to be 1 over 6. Here we have 2 ohm, so the conductance right here is going to be 1 over 2. And here we have 7 ohm, so the conductance is going to be 1 over 7. Those are our 3 conductance. And let's look at the next part. Find the element of the conductance matrix. So find the element. So here what we are going to do is we are going to put G11. So in this case what we are going to do is we are going to look at the V1 voltage and see what are the conductances connected with this voltage, and we are going to add them together. And if you look at this one, 1 over 2 is connected with V1, this node. We are looking at this node. So 1 over 2 is connected, 1 over 6 is connected. So we are going to add those two. So this is going to be 1 over 6 plus 1 over 2. And here we can take 6 as common denominator, and that's going to give us 1 plus 3. So this is going to be 4 over 6. That's equal to 2 over 3. And if you calculate this one, you should let's leave it at this one. Okay, 2 over 3 is good. Now let's look at the G22. Now what we have to do is we have to look at the V2 node, V2 voltage, and see what are the conductance connected with this one. And here we have 1 over 7 is connected, 1 over 6 is connected with this one, so we have to add both of them. So this is going to be 1 over 6 plus 1 over 7, and here we can take 42 as our common denominator. If we take 42 common denominator, this is going to be 7 plus 6. 7 plus 6 is 13. 13 divided by 42 is going to be 1 over 4. So 1 over 4 is going to be just, is it correct? 7 plus 6, 13, 1 over 4. Yeah, let's leave it as this one, right? Actually, it's not 1 over 4. 13 times 2, 26. It's going to be just 13 over 42, right? So we are going to leave it like this. And then the next step is between each 2 nodes, what is the conductance. So here we have V1, V2, and we have only one conductance between that is 1 over 6. So this is going to be our G12 and G21. And here we have to do one extra thing, like 1 over 6 is the conductance between that, but we have to put a negative sign in front, right? Now we have to, the next step is set up a node equations in matrix form. Here what we do is, so this 1 1 2 2 represents this column number and the row numbers, and we know that first row, first column we write G11, and second row, second column we put G22. If you studied linear algebra, you know already that. And here we are going to put this value in the first row, first column. So this is going to be 2 over 3. And then G22, second row, second column, 13 over 42. Right, so this is what we have. And this one, the conductance between that is going to be in the other diagonal. So that's going to be in the opposite diagonal. So here we are going to have minus 1 over 6 in this one and minus 1 over 6. Now what we are going to do is we are going to use the Cramer's rules to find this V1 and V2. Now in order to do that, we have to know one more variable, like this is V1, V2, and now we have to look at the current sources. Like when we look at the V1, and if it's going to this one, it's a +3. So we put +3 right here, and we don't have any other current sources entering V1. We only have this one, and V2 we have 12 ampere is going out of this one, so we put -12. And we have any other, we don't have any other entering or exiting, so this is going to be it. And now what we have to do, we have to use the Cramer's rules to find this V1 and V2. Cramer's rule is basically we find the determinant first using AD minus BC, because we have 2 by 2 matrix, so we can use AD minus BC. So this is going to be 2/3, and in the other side we have -1/6, here also -1/6, and 13/42, right? AD minus BC is this, like we have matrix arranged A, B, C, D. We cross multiply this AD and subtract this BC. So if you do that for this one, you will get 0.179. And again, we have to swap this one. To do the Cramer's rules, what we do is we swap this one with the first column and then find the determinant. So if you swap this value with the first column, you will get 3/-12, and the other two are going to remain the same, right? So other two is going to be -1/6 and 13/42, and now you have to use AD minus BC. So that's going to be the determinant, and if you find the determinant, that's going to give you -7.5. And again, for the second one, we have to do the same thing. Now we have to swap this one with second column and find the determinant. Now if you swap this one with second column, the first column remains the same. So this is going to be 2/3 -1/6, and the second column is now, it's going to be 3 minus 12. And if you find the determinant, that's going to be equivalent to -42. Actually, not -42, -7.5. This is actually, this one is -1.071, and this one, third one, is -7.5. Right? So now we have all the three things. Now we can go ahead and find our V1 and V2. To find V1, what we do is we plug this first variable, that first determinant, the number one determinant, that is -1.071, divided by the original determinant, that is 0.179, and that will give you -6 voltage. So this is our V1. Now to find the V2, again same process. Here what we do is we put this second determinant we found, that is -7.5, and divide this one by original matrix determinant, that is 0.179, and that's going to give you -42 volt. Now we have found out V1 and V2. Now if you want, you can also find the currents. Let's say we have this one I1, and let's call this one I2, and let's call this one I3. Now if you want to find the current, now let's get rid of these parts. We need space to calculate this one. Okay, let's start with the I1. And we know that I1 current is voltage drop over the resistance. So here is starting from 0 minus V1 value we calculated, that is -6. So -6, that's going to be +6, right? +6 divided by 2, that's going to be 3 ampere. And I2 is going to be again 0 minus, and V2 value we calculated, that is -42, minus -42, that's going to become +42, divided by 7, that's going to be 42 divided by 7 is going to be 6. So 6 ampere. And I3, starting from V1 and going to V2, V1 minus V2. So V1 is -6 minus -42, so that's going to become +42, +42 minus 6, that's going to be 36. 36 divided by 6, that's going to give us again 6 ampere. So these are the three currents we are going to get according to this. Like, also the direction is correct because we are getting all positive answers. So if the answer is positive, this is the direction, right? And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.